by a single push button on the anti-ice overhead panel. Wing anti-ice can be used to prevent ice formation or to remove ice accumulation from the wing leading edges. Extended flight in icing conditions with slats extended should be avoided. The wing anti-ice valve in each wing is electrically controlled and pneumatically operated. Pneumatic air is provided to each wing anti-ice valve by the respective side of the pneumatic system. When the wing push button is selected on, the valves are signaled to open. If pneumatic pressure is available, the valves will open to provide hot air to the 3 outboard slats of each wing. If the wing push button is selected on when the aircraft is on the ground, a timer allows the system to operate for 30 seconds, after which the wing anti-ice valves will close. This feature allows the crew to test the system when the aircraft is on the ground. Now, if the wing push button is selected on when the aircraft is in flight, the system will operate until the crew selects the push button to off. Selection of off causes both wing anti-ice valves to close. Now note, with loss of normal electrical power, both wing anti-ice valves fail to the closed position. When the wing push button is selected on, the blue on light in the push button illuminates, and a green Wing A-Ice memo displays on the engine and warning display. Additionally, the wing anti-ice operation is displayed graphically on the ECAM bleed page. When the wing push button is selected off, the on light goes off and the Wing A-Ice memo blanks. The amber fault light illuminates briefly when the valves are in transit. This is a normal display condition. You can click the labeled hot words and the push button to view system operation and displays. The amber fault light illuminates in the push button, and an ECAM caution appears if the valves are not in the selected position or the available pneumatic pressure is too low. When the wing anti-ice is selected on, the EPR limit is automatically reduced and the idle EPR is automatically increased. Therefore, selection of wing anti-ice on during climb will reduce the available thrust, and selection of wing anti-ice during descent may extend your descent profile. Engine anti-ice is used on the ground or in flight when icing conditions exist. Pilots shouldn't wait for ice buildup, but should select the system on before or as soon as temperature and visible moisture meet the specified criteria, especially if the aircraft is cold-soaked. Engine anti-ice is controlled for each engine by a push button on the overhead anti-ice panel. Pneumatic air is directly supplied from the respective engine's high-pressure bleed manifold. When the engine 1 or 2 push button is selected to on, the engine anti-ice valve is signaled to open and high-pressure bleed air is delivered to the engine nacelle area. When an engine 1 or 2 push button is selected on, the on light in the push button illuminates blue, and the green memo Engine A-Ice displays on the engine and warning display. The memo displays if one or both engine anti-ice push buttons are on. When the engine anti-ice push button is selected off, the on light goes off and the memo blanks. With engine anti-ice selected on and operating, continuous ignition is automatically provided. If engine 1 or 2 is selected on after engine start, there may not be adequate pressure to open the anti-ice valve on the engine. If a valve does not open as expected, the normal procedures allow for a slight run-up of about 5% N2 to provide additional pressure for valve operation. As soon as the valve opens, retard thrust to idle. The amber fault light illuminates in the push button, and an ECAM caution appears if the position of a valve disagrees with the respective engine 1 or 2 push button selection. The amber fault light illuminates briefly when the valves are in transit. This is a normal display condition. An engine anti-ice valve fails to the closed position if there's no engine bleed air pressure. On the other hand, if normal electrical power is lost and bleed air is available, the engine anti-ice valve fails to the open position. When the engine anti-ice is selected on, the EPR limit is automatically reduced, and if necessary, the idle EPR is automatically increased to provide the required air pressure for operation of the engine anti-ice. Therefore, selection of engine anti-ice during climb will reduce the available thrust, and selection of engine anti-ice during descent may extend your descent profile. Window heat is used for all flight operations regardless of weather conditions. The aircraft uses electrical heating for anti-icing each windshield and demisting the cockpit side windows. Two independent window heat computers, or WHCs, one on each side, automatically regulate the system, protect it against overheating, and indicate faults. Heat to the windshields is provided in a normal mode in flight, but is provided in a low heat mode on the ground. The other windows are provided heat at one level regardless of flight or ground condition. Window heat can be selected to operate in the automatic or manual mode. The probe window heat push button determines the operating mode, automatic or manual. If the probe window heat push button is selected to auto, window heat comes on automatically when at least one engine is running or when the aircraft is in flight. If the probe window heat push button is selected to on, the blue light in the push button illuminates and window and probe heat comes on. If manual selection is desired before engine start, the crew will select the push button on. Otherwise, the heat will come on automatically after the first engine start. Window and probe heat both require normal electrical power. You can click the hot words on this frame and the push button to see the results. Probe heat is used for all flight operations regardless of weather conditions. Electrical heating to the probes is controlled by the probe window heat push button. Heat is provided to the PDOT heads, static ports, angle of attack probes, and total air temperature probes. Note, on the ground the TAT probes are not heated and the PDOT heat operates at a low level. The in-flight TAT heat operation and the PDOT heat normal heat level automatic changeover is fully automatic. 3 independent probe heat computers, or PHCs, automatically control and monitor the captain's probes, the first officer's probes, and the standby probes. The PHCs also protect against overheating and indicate faults when they're detected. When the probe window heat push button is selected to auto, the probes are heated automatically if at least one engine is running or when the aircraft is in flight. If the probe window heat push button is selected to on, the blue light in the push button illuminates and the probe heat comes on. If this manual mode is desired, the crew selects the push button on before engine start. Probe heat requires normal electrical power. Captain PDOT and angle of attack is powered by essential buses. You can click the hot words on this frame and the push button to see the results. Each front windshield is equipped with a 2-speed electric-powered wiper. There is a rotary switch for control of each pilot's wiper. The wiper speed can be selected to slow, fast, or off. The off position will cause the wipers to park out of view. Wiper operation requires normal electrical power. Rain repellent is stored in a bottle in the rear of the cockpit. The bottle is equipped with a pressure gauge that displays the nitrogen pressure in the bottle. When the needle of the gauge is in the yellow sector, the bottle should be replaced. Additionally, when the bottle is low on repellent fluid, a refill float will be in view to indicate the bottle should be replaced. There is one rain repellent push button for each pilot windshield. When the pilot pushes a button, a timer applies a measured quantity of repellent on the associated windshield. The rain repellent will not operate when on the ground with the engine stopped. Rain repellent should never be applied to dry glass and should be used in moderate to heavy rain. The external visual ice indicator is installed between the two windshields. The indicator also has a light. Preliminary cockpit preparation. Before electrical power is applied to the aircraft, ensure the wipers are selected off and check that the probe window heat is selected to auto. After engine start, select the engine anti-ice as required by conditions. The flight manual normal procedures explain static run-ups on the ground to ensure no ice accumulates on the spinner, fan blades, and low compressor stators. Select the wing anti-ice as required by conditions. If the wing anti-ice is selected on when the aircraft is on the ground, the anti-ice valves will open for 30 seconds and then close. They will open upon liftoff. After takeoff and climb, select the engine anti-ice and wing anti-ice as required by conditions. Descent. Select the engine and wing anti-ice as required by conditions. Make note that the engine idle speed will increase when the wing or engine anti-ice is on. This may reduce the descent path angle, and the pilot can compensate for this by increasing the descent speed and/or extending up to half speed brakes. After gear are down for landing, the wing anti-ice should only be turned on for the final phase of the approach if severe icing conditions are encountered. After landing, wing anti-ice shuts down upon landing. If the landing was made in icing conditions, or if the runway was contaminated with slush or snow, don't retract the flaps or slats until the ground crew has inspected them for obstruction of ice or snow. The same requirements for operation of engine anti-ice exist after landing as before takeoff. Additionally, engine run-up may be required to remove ice buildup on the engine or to keep ice from accumulating. Now, let's answer some questions.